Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will discuss the high speed ring and traveler in this session. So, earlier what we have seen in last session we have seen the what are the different types of forces acting on the traveler and how the traveler generates heat, and the heat dissipation is a problem that we have discussed in the last session. And in the high speed, when the ring high speed is spinning, so that the problem of traveler burn is very severe. So, that is why we have to develop high speed ring and traveler. So, one of this is anti-wedge ring in combination with elliptical traveler. So, anti-wedge ring is that this is the elliptical traveler and here is the anti-wedge ring, where one surface is one flange is projected. So, first high speed ring, so high performance ring is there. So, enlarged flange inner side, the inner side flange will be enlarged to provide higher contact area, and flattened upper surface is flattened, so that it provides the higher more yarn space. So, rubbing with the yarn is less, more passage. So, for elliptical traveler it is actually anti-wedge ring is with the elliptical traveler, and elliptical traveler advantage is that the center of gravity is lowered and they work in combination. So, anti-wedge ring and elliptical traveler they work in combination. So, lower center of gravity is the target to have stable movement over the ring, stable movement of the traveler over the ring. Another is the cropped ring, flattened upper surface, that is a standard ring, more space of yarn. So, if the ring surface is cropped and this is the traveler, so there will be more space for the yarn. Oval or flat traveler can be used because we have already cropped the upper surface. So, space is created. So, oval or flat traveler can be used here. So, why? Because we have to reduce the center of gravity to have stable movement, and for all current traveler more space as compared to anti-wedge ring, most widely used. A cropped ring is most widely used. Now, the orbit ring or inclined flange orbit ring, this is the inclined flange. So, inclined flange ring it is basically used where the contact area, you can see the contact area is very high. So, here the heat dissipation from the traveler to the ring surface will be very high, very quick. Large contact in the inner flange, good heat transmission, okay. Compensation of the forces, higher speed enables traveler speed to be increased by 15% because of the high heat transmission, suitable for synthetic fiber because synthetic fiber has got a melting point. So, if the traveler temperature is reduced, we can reduce the temperature, that means synthetic fiber can be used. Now, ring material, ring should be very tough material and hard, it should be harder than traveler, because traveler is a smaller component which can be replaced quickly if it damaged, but ring should run for longer time, that is why ring should be harder than the traveler, and its surface should be smooth and it should not be too smooth. So, smooth surface is for smooth running of the traveler over the ring surface, but if it is too smooth, the problem would be that the development of the natural friction, natural actually lubricating agent will be problem. So, problem of lubricating film will be there. If it is very smooth, so there will be problem of lubricating film, and this lubricating film is important for running of the traveler, smooth running of the traveler. And for the features are, it is a good but not too high surface smoothness, that is what we have discussed, even surface, perfect roundness, there should not be any eccentricity, any ovalness should not be there, even and good surface hardness, its hardness should be more than the traveler. Long operating life, and ring and bobbin tube circumference, the diameter ratio is 2.1 2:1 to 2.2:1. So, that should be the ratio, exactly centered relative to the spindle. So, it should be exactly centered, otherwise the movement of the traveler will be affected. So, materials of the ring is the following materials are used: the hardened steel, nitride steel. So, there are different types of materials are used. Modern rings usually feature surface coating. So, the objective is to reduce the friction. So, ring is coated to reduce the friction and wear and tear of traveler, and also in the ring surface, the prevent the corrosion, okay, and simplify running in time. Running in time is the time for initial development of the naturally lubricating film on the ring surface. So, coating, there are different types of coating: oxide coating, nitride coating. So, these are the hard chrome coating, nickel coating, ceramics coating. So, these are the different types of coatings available in the ring surface to reduce the friction, wear and tear. And as we have discussed, we have mentioned the fiber lubrication. So, natural fiber lubrication should be there. So, what is the traveler moves on the lubricating film. So, it if it moves on the ring surface, the high friction will be there. So, there must be some lubricating film, and this lubricating film is generated from the fiber lubrication. So, wax and cellulose dust are the lubricating material. Platelets, okay, are continuously scraped off. So, from the fiber, and it comes on the surface of the ring. Lubricating film is dependent on the yarn fineness. So, if the yarn becomes very fine, so lubricating film generation will be less. So, for finer yarn we cannot run at high speed. So, there will be damage of the ring and traveler. Yarn structure. So, yarn structure, if it is very smooth, so lubricating film will be will not be developed. fiber raw material. Depending on the type of raw material, the lubricating film generations are there. Traveler mass, higher the traveler mass, the lubricating film generation will be quicker. Traveler speed, height of traveler bow. So, that is why, because if the height is very wide, that means the lubricating film generation will be slower. So, for yarn more than 80 count, that is very fine, low traveler mass is used. So, that is why low lubricating film is generated. So, as low lubrication, then we cannot have higher speed. So, speed has to be lower. So, for finer count we have to reduce the speed, that is mainly for low lubrication. Now, for more lubrication if you can generate, then we can have higher speed. So, for a new ring, there is a term running in time is there. For new ring, when we are using replacing the ring surface, new ring, so no natural lubrication is there, fiber lubrication is there. So, initially low speed is there, we have to run with a lower speed or lighter traveler. If we start at the high full speed, then the traveler burnout will be there, okay. And also there will be higher yarn tension due to higher friction. So, yarn breakage will be there. So, that is why for new ring we have to run the machine at lower speed. During this time the ring surface is smoothened and fiber lubricating film is built up. So, it gradually builds up and cover the surface of the ring. Now, we have at this time the traveler gets damaged frequently. So, we have to frequently change the traveler and we have to increase the speed in steps in. Okay. Now, select the correct ring traveler, but reduce the spindle speed by 15 to 20%, okay. Or normal spindle speed and ring traveler can be of lighter weight. So, either we can use for use normal speed, but with a lighter traveler, or else normal spindle speed reduced, we can reduce the spindle speed itself using the normal traveler. So, frequent traveler change is there, fast traveler change within the 15 minutes, then 30 minutes. So, there are sequences. So, this is done at initially just to allow the fiber lubricating film generation on the ring surface. So, this is called the running in time. So, after it generates, okay, after repeated traveler change, now then the finally the spindle speed can be increased in the stage of the normal spindle speed, maximum spindle speed we can run. With yarn finer than 80 Ne, the running in is an even more delicate. Okay. In this case, speed should be reduced by 20 to 30% and the ring smeared from the time to time and oil soaking should be there. So, that means here the lubricating film generation is not that great. So, that is why we have to sometime the oil soak felt is used to lubricate. Another development in ring is the rotating ring, but which is not successful commercially. this is to prevent the heat generation. Basically what happened, this is a ring, and if there is a traveler, the movement, the relative movement of the ring traveler, which is actually generating the heat. Now, if we can reduce the relative movement, that we can do by, if the ring also rotates at the speed of the traveler, then there will not be any relative motion and friction will not generate and heat will not generate. So, we can theoretically we can have a very high speed in the ring spinning if we use the rotating ring. By reducing the relative velocity practically 0, practically 0 means the ring and traveler will rotate at the same speed, approximately the rotating rings floats on air cushion. The ring is actually floating on the air cushion and it acts as a rotor. So, ring will act as rotor on the air cushion. At start what happened, only traveler rotates, only traveler will rotate, because this, the ring has got its own inertia because of its own weight. Although it floats on the air cushion, initially the traveler will start rotating by the yarn drag. Gradually, due to the friction, the ring will start rotating. Then the ring rotates due to the contact pressure, frictional contact. Now, the main problem here is that the costing is very high. So, that is why commercially it is not successful. The cost of this type of ring, so you need additional air cushion, floating air cushion contact arrangement for each and every ring. So, that is maintenance is very costly, and for that, to maintain that, we have to have higher gauge. That means, the number of spindle per machine for a certain machine, for normal case whatever the number was there, here we have to have less number of spindle. That means, per unit floor space the productivity will be less. And the main problem is the brake device is required. So, because in the normal case, in case of any breakage, yarn breakage, traveler immediately stops, because traveler is a lighter weight and due to friction it will stop, it has got lower inertia. But ring being a heavier one, so when it is rotating at very high speed, at that speed when the any breakage takes place, so ring will keep on rotating, because it is on the floating on the air cushion. So, it will keep on rotating. So, for that we need additional brake device to stop the ring from further rotation. Other factors, that is yarn tension, energy consumptions are there. So, higher energy consumption will be there, because the high yarn tension will be there, because it is as it is used to rotate the ring. Now, the traveler's main function is to impart twist and enables winding. Winding is due to the difference in peripheral speeds, high pressure on ring due to the centrifugal force, and this is up to 35 Newton per square millimeter, results high frictional force, and that is heat generation. So, S equal to pi dt, dt is the diameter of bobbin at time t, and ns spindle speed minus nt. So, the traveler can be classified based on the shape of the traveler, mass of traveler and its raw material, finishing treatment of material, wear profile. So, there are various ways to classify the traveler. Let us see one by one. And arc height. The traveler must be shaped matching with the ring frame, it should exactly match. Okay. So, that the single contact surface with maximum contact area is created. Maximum contact area is created due to it is basically for greater heat dissipation. Okay. That is tabular shape. The bow of the traveler should be as flat as possible, because it is to reduce the lower the CG, center of gravity, in order to keep the center of gravity low, thereby improve smooth running. So, there is less tilting of the traveler during running. However, the flat bow has problem, it actually it has reduces the yarn passage. So, we have to take care that it should not prevent the smooth movement of the yarn. There should be adequate space for yarn passage. If the yarn clearance opening is too small, what will happen? The rubbing will take place, the leading to rough yarn yarn and fly generation, yarn hair generation will be there, and ultimately yarn quality will be deteriorated and formation of melt spot for the synthetic fibers due to the rubbing. And this melt spot created here in the ring traveler zone will affect the dyeing behavior. Okay. If it is piece dyeing or yarn dyeing, so in that spot the dark spot will be created. Now, based on the shape, that must be shaped accordance with the ring in the contact zone. So, there should be contact of flat bow, lower center of gravity, stability is there, lower yarn clearance, fly, hair and melt spot. So, common shapes of traveler: C shaped traveler, flat or oval traveler, elliptical traveler, N shaped traveler. So, these are the common shapes. Now, traveler wear profile, if we see, the wear profile influences the both the behavior of traveler and certain yarn characteristics. So, wear profile actually controls the heat transmission. So, contact surface of the air ring. So, higher contact surface mean higher heat flow, quicker heat flow, smooth running, thermal transmission will be better, yarn clearance, roughening effect will be there if the wear profile is not correctly selected, and hairiness generation will be there. So, that will create the hairiness. Now, traveler wear profile, we can see there are different types of traveler wear profile. This is circular, then the flat shape. So, these are the different shapes. The contact surface of the ring, smooth running, heat dissipation, thread passage space, all these things they control, and certain yarn properties they control, strength, hairiness. So, now we can see here this is the schematic diagram of the wear profiles. So, this is a circular one electrical flatter one and the semicircular one. Now, here we can see the ion passage resistance S2 by S1. So, this is S1 and here it is S2. So, when we are winding S2 by S1, the resistance will be 1.5, 1.7 to 1.8. So, these are the resistance here. That means, here if we see this, the lowest resistance is given by the circular one and highest is the flat one. Now, if we see the heat dissipation, if here through the radiation and convection it is 1 and through cross section it is 1, and through cross section, because as the cross section of the all these travelers are same, because the mass is same, only the shape is changed, where we can see the for flat one heat dissipation through radiation and convection is maximum here. Okay. So, we can use this flat one, flat wear profile for better radiation and convective heat loss. So, traveler speed we can achieve for that. So, we can achieve the maximum traveler speed here, okay, because of the higher heat transmission. Now, traveler material which generates less heat, dissipate heat fast, so have sufficient elasticity for easy insertion and retain the original shape. So, good elasticity should be there and it should be inserted easily to the ring. Friction between ring and traveler should be minimal. It should have excellent wear and tear resistance. So, wear resistance for long time. Hardness of traveler should be less than the ring. So, it should not damage the ring surface. So, travelers used in short staple spinning, therefore, made almost exactly, it is exclusively on the by the steel. However, pure steel does not ideally fulfill all the requirements. Traveler manufacturers have therefore been attempted to have different materials, improve material. So, electroplating is one of the way. So, different types of metal plating is there, chemical treatment is done. So, made of steel, not pure steel, hardened steel, nickel or silver plated. Chemical treatment is done to increase the friction, reduce the friction. Now, based on traveler mass, the traveler is classified. Okay. The mass of the traveler determines the degree of friction, okay, of the traveler, and the which actually in turn increases the yarn tension. If the mass is low, what will happen? Balloon becomes larger. So, larger balloon, so the corp is too soft because of the lower tension. The amount of material taken up by the corp will be smaller. So, per corp will be too small. So, that is why your number of doff will be frequent. On the other hand, if it is too high, so that mass is very high, then high tension and frequent breakage will be there. So, mass must be perfectly adjusted based on the spindle speed, on the yarn count. So, if there is a choice between two traveller weights, heavier is usually preferred, since this results in high cop weight. That means, the per drop there will be maximum high more number of more quantity of material. So, dropping frequency will be reduced. So, running efficiency will reduce, smoother running of traveller and better heat dissipation. So, higher mass means better heat dissipation will be there. So, we can see the table here. Now, in this table, the in ISO system, the new standard system specified as mass of 1000 traveller in gram. So, that is how we use, this is the ISO system, mass of traveller. So, we can see this is a text, any text, if we increase the text, that yarn become coarser. So, we use the heavier traveller, and when we go the very fine yarn, so the traveller mass will be low. Now, you can see traveller mass, if the traveller mass increases, it increases the friction, and so the winding and balloon tension also increases, which increases the breakage. Now, if the traveller mass increases, reduces, the balloon size will increase. So, with the reduction in traveller mass, balloon size reduces, and which increases the softness of package, and material per bobbin reduces. So, the doffing frequency will increase, and mass is selected as per the yarn count, as we have discussed. So, finer the yarn count, so it will be lower mass. So, you can see that 120 NE, very fine count, the traveller number will be 9. So, in this way we can select the traveller, and traveller masses are there. So, traveller weight determines based on the number by the following pattern, following parameter is used: so yarn twist, knitting, and lighter travel. So, that means for knitting yarn, okay, the lighter traveller is used. So, yarn twist means when for knitting we use the lower twist, this is the application lower twist yarn. So, for lower twist we use the lighter traveller. So, for blend or synthetic fiber we use 1 to 2 number heavier traveller, spindle speed, high spindle speed, lighter traveller is used, and smaller ring lighter traveller is used, and larger ring. So, larger balloon size we will use heavier traveller. So, these are the simple guidelines how to use the travellers. High contact pressure up to 35 Newton per square millimeter is generated between ring and traveller. It is mainly due to the centrifugal force. The pressure leads to generation of heat. Low mass of the traveller does not permit the dissipation of heat generation within a short time. As a result, the operating speed should be kept low for lighter traveller. Heat production, the ring traveller is around 300 to 400 degree Celsius, and this has to be dissipated in milliseconds by traveller into the air. So, that is the main challenge. Now, try to see the different parts of the traveller. Here height of the bow, so that we can adjust the height of the bow. It should be as low as possible for stable running of the traveler. It should also have sufficient yarn space. So, we have to select in the modern traveler, the height of the bow has to be selected. So, it should be as low as possible for stable running, so lower CG, but at the same time there should have sufficient yarn space. Now, ring contact area with ring, this is the contact area. This area should be more uniform and smooth and continuous for the best performance. This area, more area means more contact area means smooth running, better heat dissipation. Okay. And yarn passage is through this is the yarn passage in accordance to the count. So, according to the count we have to set this yarn passage. Inner width, this varies according to the traveler profile and ring flange. If the ring flange is more, so inner width will be more. It should be according to the ring flange. And toe gap, this will vary according to the traveler number and the flange width of the ring. So, toe gap, and these are the wear section. It plays an important role in yarn quality and life of the traveler, that we have already discussed, and also the heat dissipation. And traveler damage, when the spindle speed is increased, the friction works between the ring and traveler increases as the third power of the spindle speed. So, that is how the friction increases. Consequently, if the speed is too high, the traveler sustains thermal damage and fails. If the traveler speed is raised beyond the normal level, the thermal stress limit of the traveler is exceeded, and drastic change in the wear behavior of the ring and traveler. So, that we should be careful, we should not increase the traveler speed to beyond certain level. Going to the strongly increased addition between the ring and traveler, welding sometime may take place. So, that if that means it is at high pressure and high temperature is there, that welding action may take place. These scissors inflict massive damage not only on the traveler, but also on the ring. So, that welding effect is dangerous, that means it will affect the damage the ring. Due to this unstable behavior of the ring and traveler system, the wear is at least an order of magnitude of higher than during the stable phase. Traveler temperature reaches between 400 to 500 degrees Celsius, and the danger of traveler annealing and is there, and failing is very great. So, at this speed, at high speed, if the temperature reaches around 400 to 500, so traveler will fail due to the thermal damage. So, we have completed the traveler ring and traveler section, and now in the next session we will discuss the forces on ring and traveler. So, till then, thank you.